We all know that the Nazis loved themselves a bit of posh aerospace tech, hence the Messerschmitt 262, the world's first jet fighter, the Messerschmitt 163, the world's first rocket interceptor, and the Arado 234, the world's first jet bomber. But what is less known is that those famous examples that actually made it to service are just the tip of the iceberg, and that for everyone like them that roared their way into the historical zeitgeist, there are another 10 that for one reason or other failed and as a result remain but enigmas that languish in obscurity. But today, we're going to shine a light onto 5 of them, so let us begin. Alright, let's begin with the Messerschmitt P1101 jet fighter. It has its genesis in the 1TL Jager competition of July 1944, which was announced by the Ministry of Aviation, RLM, and was all about trying to find a simpler, more reliable, and above all else cheaper alternative to the Messerschmitt 262, which despite being the world's first operational fighter jet and a truly innovative bit of kit, was none of those things. The RLM had a vague idea of what they wanted too, as they stipulated that the new aircraft should be a single-seater, top out at 1,000 kPa, and have an aerial endurance of at least an hour, as well as a bit of armor to protect the pilot and 2 30mm Mk108 cannons, as well as using a Heinkel HES-011 engine. Now, knowing a thing or two about jets by that point, Messerschmitt rose to the challenge and produced an initial design for what would become the P1101. Sketched by Waldemar Voigt, who had been the project lead for the M264 bomber and ME-163 that we mentioned a moment ago, it featured an all-metal fuselage, a single Heinkel HES-011 buried deep within the fuselage, twin air intakes at its wing roots, much like a Cold War-era British V-bomber or Hawker Hunter, and a V-tail configuration. This did not spark much joy among the RLM bigwigs, however, when it was presented to them in September 1944, and so Voigt returned to his drawing board and created an updated preliminary design, one that saw the twin air intakes replaced by a single big one up in the nose, and the moving back of the cockpit, which had to be shifted to accommodate said new air intake. The V-tail was also replaced with a more conventional design. The most interesting addition of all, however, was the variable sweep wings, i.e. wings that can be moved into different positions. It was quite a crude system, with them only able to be adjusted when it was stationary on the ground rather than when in the sky, as you might initially imagine, but still, this was the first aircraft to ever incorporate such a system, so it was certainly a bit of a big deal. Ultimately, however, despite not having a fully RLM-approved design, very little came of the project, as labour shortages, constant bombing, and technical development hiccups meant that come early 1945, not even the first prototype had been completed. The worst problem, by far, was the fact that Messerschmitt couldn't even get their hands on the engine they wanted, the component that had to be figured out first and foremost, as so many other systems of the aircraft just couldn't begin to be engineered before it was in place to build around. Chiefly, this was because Heinkel, themselves being beset by labour shortages, constant bombing, and technical hiccups, simply couldn't get it out of the factory fast enough, with a mere 19 units being produced come the war's end, all of which were hotly fought over by many experimental aircraft programs that Germany was running. Voigt, rather prudently, eventually gave up ever getting his hands on one, and instead opted to use the much more available Junkers Jumo 004 instead. This engine, which also powered the 262 and 234, was, to all intents and purposes, a little but posh scrap. It'd last 15 operational hours, if you were lucky, before it completely wore out. Its turbine blades would also often shear off and get sucked into the engine, completely destroying it, and it was horribly inefficient. But hey, I mean, a crap engine is better than no engine. The power plant change was not enough to see the P1101 through to completion, however. By the time all of the faffing about with the engine had been resolved, the Reich was at the point of near total collapse, with the armies of both the Western Allies and the Soviets closing in to deliver the coup de grace. Voigt and his team kept working till the last minute, however, for what it was worth by that point, with their progress only being interrupted by the arrival of American tanks at the Messerschmitt Research Center, at which point they surrendered and happily showed the Americans what they'd been working on to try and win some brownie points with their captors. I mean, this worked. The team ended up being relocated to the United States via Operation Paperclip, and all found gainful employment within the American aerospace sector, with Voigt himself ending up with Vought, where he would lend his expertise to the development of the F-7U Cutlass. As for the unfinished P1101, however, it ended up being transported to the US, where it was pulled apart and examined by Bell Aircraft. Their chief designer, Robert Woods, was very impressed by the variable wings and went on to refine the idea further for the Bell X-5, the first aircraft to be able to adjust its wings while in the sky. Alright, next we arrive at the DFS 346, which was developed in the final stages of the war. DFS, if you're wondering, because it isn't exactly the most familiar name, refers to the German Institute for Glider Research, a state-owned enterprise that brought all of Germany's previously privately owned glider companies together under one roof. As for the 346 specifically, it bizarrely was the exact opposite of a glider, a rocket-powered research plane that had the aim of smashing the sound barrier. As for why a glider company of all things found itself attempting to break the sound barrier, that would be because of one of their employees called Felix Kracht. He made quite a name for himself, both in the world of glidering and in Germany more generally, thanks to his equal skill in both building gliders and then flying them in various exciting ways, an example of which comes from 1937 when he designed the high-performance FVA-10B Rhineland and then flew it over the Alps. Because of his quasi-celebrity status, when Kracht, for reasons that have been lost to history, barged in to see DFS's management and announced that he wanted to build a plane that'd break the sound barrier, rather than being told to f*** off as basically any other employee would, he instead had cash hurled at him and he was told to get to it. As for its design, a notable feature was its backward swept wings and a highly streamlined fuselage, which were designed to reduce drag and enable higher speeds. But while notable, they're both ultimately pretty normal design quirks compared to the pilot's positions, because that was prone, as in lying down on one's front. A seemingly bizarre choice had actually some pretty reasonable thinking behind it. Firstly, not having a cockpit poking out helped to avoid compromising the highly streamlined fuselage, and also the Germans had discovered that laying prone actually allowed a pilot to tolerate much higher g-forces than if he was sat upright, because it lessens the amount of blood that is pulled away from the brain during high g maneuvers. But wait, there's more weirdness, because the 346's design also included an escape capsule. Basically, if the flight ended up going a bit whoopsie-daisy, the pilot could separate the cockpit from the fuselage, which had a built-in parachute for descent, and then when closer to the ground, he would jump out and use his own personal parachute in the normal manner. As for this prospective supersonic plane's power, it was to come from two Walter HWK-109 rocket motors. For the day, these were pretty decent units and were intended to propel the 346 not just through the sound barrier, but all the way up to Mach 2+, and even take it up to altitudes as high as 30,000 meters. They were arranged in quite an interesting manner too, because only one motor would actually be used for speed, with the other one intended to provide sporadic bursts of power to help maintain velocity and altitude. Unfortunately for Kraft, however, he had proposed his design in 1944, so naturally it never got anywhere near completion before the war's end. He managed to knock out some blueprints and do some scale model wind tunnel testing, but that was about it. But that's not the end of the story today, because the facility in which Kraft was working ended up falling into the Soviets' hands, and they were very interested in his work indeed. So, is this part of the story where we tell you that they brought Kraft's vision to life and banged in a cheeky breaking of the sound barrier themselves mere moments after the Americans did with the Bell X-1? Well, no, they didn't, not at all. As it turns out, would you believe it, a glider designer wasn't exactly that qualified to be making record-breaking rocket planes, and so Kraft's design was actually just a bit shit and never really worked. Not for want of trying on the part of the Soviets, however, because they piled serious resources into the 346 to try and get it to work. They gave it a go as an unpowered glider in 1947 just to test its aerodynamics, and it crashed. They also tried again in 1951 with a proper big boy rocket motor fitted, and it crashed again. So the project was abandoned. For our third aircraft today, let's take a look at the Junkers U322 Mammoth, or Mammoth. The development began in late 1940, a time when Germany was starting to see some real success with its glider-deployed airborne units, having used them extensively during its invasion of the lowlands and Scandinavia. But as successful as they were, there was a problem. Their go-to gliders, things like the DFS 230, were just a tad small, and thus Germany's airborne forces couldn't really take any serious hardware into battle with them. The 322 was intended to be a solution to this problem, a seriously big glider that would be happily able to carry tanks and larger artillery pieces. Its development was made a top priority because at that time the Germans were sketching out their plans for Operation Sea Lion, the invasion of the United Kingdom, where on account of the English Channel the ability to transport serious amounts of heavy hardware by air was naturally deemed essential. As for why Junkers were chosen to develop such a machine, that was because they were one of Germany's top aircraft manufacturers with a proven track record of developing incredible aircraft such as the Ju-87 Stuka dive bomber and the Ju-88 medium bomber, both of which were serving Germany very well indeed. One small problem soon presented itself, however, because all of those aircraft were made of metal, and the 322 was to be made of wood, a material that Junkers hadn't seriously worked with for many years. The basic idea itself was a smart one, to be sure, because wood was an abundant, non-strategic resource that Germany was never going to run out of. But it turned out that wood is a very different beast to metal, and so Junkers engineers majorly struggled to get their heads around it. Nevertheless, they persisted, and come October 1940, they had the basic design worked out. It was to be an almost flying wing kind of design, a genius move that created a simply enormous space for cargo in the center, with a rear pointing boom to accommodate a traditional rear tail. To further maximize space, the flight crew were positioned in a gondola mounted above and to the left of the center section, nice and out of the way to leave plenty of space for anything big that had to be squeezed into its belly. To further maximize cargo space, it was to take off using a large 16-wheel trolley and land on 4 sprung skids being nice and flat and thus neither overly eating into the cargo space nor creating excess drag as a wheeled landing gear would. Some thought was even given to defense, with 3 MG-15 machine guns mounted around it in strategically located mounts. All of this looked great on paper, and Junkers were confident that their creation would happily be able to carry 20,000 kilograms worth of stuff, happily enough for a tank or up to 100 fully equipped troops. And then they began to test it out. They began by driving a Panzer III into it, and the fuselage was immediately crushed under its weight. Turns out, despite all their efforts to figure it out, wood had stumped them. They then returned to the drawing board, and after a redesign of the floor and reducing the prospective payload capacity to 16,000 kilograms, it failed weight testing yet again. The third time proved to be the charm, however, as with yet more strengthening work and further reducing the payload estimate to 11,000 kilograms, the fuselage no longer fell apart. One small problem with that, however, the 20,000 kilogram target, it was set for a really specific reason, because it was basically the exact weight of an early war Panzer III. The whole point of this project was to develop a glider that could transport serious hardware, and now it couldn't even transport their lightest medium tank. Needless to say, the Luftwaffe wasn't exactly chuffed with the development, but they pushed it through to testing anyway in April 1941, because after all, 11,000 kilograms was still about the weight of 100 fully tooled up fellas, so maybe some use for it could be found. Unfortunately for Junkers, its first test was an absolute disaster. The takeoff trolley almost bounced up and destroyed the glider, and it took so long to take off that the Ju-90 towing it almost crashed. But it gets worse, because then, after all of that, when in the air, the 322 proved about as stable as a newborn deer that's just down 15 pints of lager. At this point, its fate was sealed, and the project was cancelled in May 1941, with the 2 finished prototypes and 98 production models that were in various stages of completion all being chopped up for firewood. Let's stay with Junkers now and move on to have a look at the EF-61, a prototype high-altitude bomber. Its development began in December 1935, when Junkers, having gained a wealth of high-altitude aircraft experience from their earlier Ju-49 research aircraft, were commissioned to make a veritable Rolls-Royce of a bomber, one that would make use of a pressured cabin to allow it to fly higher than any bomber before it had, so high in fact that it would be completely out of reach of both ground-based AA systems and interceptor aircraft. 2 prototypes ended up being built, which were designated the EF-61 V1 and V2 as per the usual German experimental nomenclature. They were both powered by 2 900 horsepower Daimler-Benz DB600s, a stopgap measure intended to tide them over until the then still in development 1200 horsepower Junkers Jumo 211s could be fitted. Knowing that these beastly engines were hopefully on their way, Junkers engineers took special care with the cooling system, making sure to integrate nozzle coolers on the front of the engines that would provide more than enough airflow to really keep the new engines cool when the pilots opened up on the throttle and gave it the beans. Unfortunately, however, while the team at Junkers certainly put a lot of effort into trying to make the EF-61 a quality high-altitude bomber, they had been so hyperfixated on trying to squeeze every foot of altitude out of it that they totally neglected to think about how the measures they implemented to achieve this would affect other aspects of its performance. The worst offender, by far, was the cockpit, which, to achieve pressurization with the crude technology of the day, had really, really tiny windows. So small, in fact, that it was a struggle to see much out of them at all. Picture a tank's vision slit bolted onto a plane, and you've probably got it about right. This ended up exactly as you would expect, with EF-61V1 crashing in September 1937. Determined not to be defeated, however, the Junkers engineers then revisited EF-61V2 and made a few changes to solve the visibility problem, which included raising and repositioning the pilot seat and fitting a metal dome which could take larger windows without compromising pressurization. It was a noble effort to be sure, but it was not a successful one, as EF-61V2 also crashed in December 1937. Following this, the whole program was written off as an abject disaster and was cancelled shortly after. So, a question for you, dear viewer. What happens when a DFS-230 glider and an FA-223 helicopter decide that they love each other oh so very much? That's right, they have a special hug, and they make the Fokker Arculus FA-225 behold! This bizarre-looking thing was the result of Germany's go-to glider, the aforementioned DFS-230, having a particular problem, that being that it needed really quite a large area to land, something which was less than ideal, as on a good day it severely limited where the pilot could put it down, and on a bad day the pilot would say sod it, be reet, and then proceed to kill everyone on board as his glider belly slid its way right into something solid. By fusing the rotor assembly from an FA-223 to the top of the venerable glider, Fokker Arculus hoped that it would be able to land in much the same way as a helicopter, either vertically straight down or in a very short distance, no more than 18 meters or so. Naturally, a change this radical required quite a bit of tinkering with the base 230 design, and so a vast framework of struts was created above the fuselage so that they had somewhere nice and high to mount the rotor. This added a fair bit of weight, and so a highly strengthened undercarriage was also fitted in order to support the weight of it all. The rotor was also completely unpowered, depending entirely on auto-rotation, the natural movement of rotors from airflow as an aircraft moved through the sky to generate lift. The original wings were also chopped off, as after all, they were a tad surplus to requirements now. Development proved most quick too, with the whole process from initial idea through to working prototype only taking 7 weeks. It was a reasonable idea, all in all, and their thinking for creating such a machine is easy to follow, but alas, a reasonable idea is not always a good one, and sure enough, after a single working prototype was built, the 225 turned out to be a complete dud, and so it was quickly abandoned and saw no further development. The issues mostly revolved around speed, or rather its lack of it. We were unable to find an exact figure for exactly how slowly it approached the ground when released, but what we do know is that whatever speed it was so slow that the extra risk created by being longer exposed to enemy fire during the descent was deemed a far greater problem than any had by a normal glider. Beyond just that, the 225 was also victim of changing German doctrines. You see, early in the war, Germany was all about airborne troops. They'd invested in them big time before the war broke out and had some cracking early war successes with them during their invasions in the lowlands and Scandinavia. Inspired by that, they went balls to the wall during their invasion of Crete in 1941, conducting it using mostly airborne troops, and it turned into something of a disaster. They won the battle, don't get us mistaken, but the victory was a Pyrrhic one, with airborne casualties being large. This caused a total rethink in German airborne operations and saw the near total abandonment of mass parachute assaults in favor of occasional drops of only a few soldiers for really important occasions, with their paratroopers otherwise basically just becoming elite ground infantry. As a result of both of those factors, there was just no enthusiasm for the project by the Luftwaffe's money men, and so the project was ultimately abandoned, with just a single prototype having been made.